So yesterday we are discussing about Arduino UNO, right? And that is the IoT physical devices and endpoint Arduino. And what are the pin configuration of that Arduino UNO? Then we are going to study the fundamentals of Arduino programming. As I told, it will have the two functions. It is one is a setup function, the other one is a loop, which already explained that setup is executed only once and it runs only once, and all the initialization and setting up of the pins will be done on this, and then the setup function, as I told, it is we are going to set the pin configuration as input, right? And any variables initialization is done on the setup, and wired loop function. So after calling the setup function, loop function does its task, right? And digital write pin on, when we are going to set the pin on, it pauses for 10 seconds. That is the 10,000 milliseconds, right? So we call that as the digital write pin low. It is a off, pauses for 10,000 milliseconds, right? 10,000 milliseconds is nothing but that is a 10 seconds. And you have the digital write, analog write, digital read, and if statements and boolean variables and an analog read and serial communication functions. And even the Arduino program also uses the commands, right? This is for the single line comment. It's good to put at the top and before anything tricky. This is for multi-line comments like this. And we are going to use in Arduino programming, either we can use a single line comment or we can use a multi-line comment, right? So multi-line comment, you are already familiar with the front slash and the star, and you can extend that multi-line comment more than one line, right? And the single line, either it start from the beginning or after the semicolon, right? Then it is called as the single line comment. Normally, whenever we want to define the problem statement, we use a multi-line comment because your problem statement will not end with a single line. Now see, name of the sketch comments. So comments you can write it in the single line comment or multi-line comments also you can use. And brief description of that, then date, then setup, put your set of code here to run once. Loop, put your main code here because this is loop is a main execution part of the program. And function is a piece of code that has a name and set of statements executed. When function is called, functions are declared by its type followed with the name of the function. Syntax, type, then function name, and you will have the parameters, and you will have the statements below that. Okay. Example, int delay where is equal to analog read. See, it creates a temporary variable where read from the potentiometer and convert the value of the variable into the where. Okay. And curly brackets we use that represents the beginning of the function and end of the function. Okay. So they define the beginning and end of the function blocks. Unbalanced braces may lead to the compile errors. Semicolon, it is used to end a statement and separate elements of a program. Syntax will be int x is equal to 14. Okay. So multi-line comments is enclosed with the braces. Multi-line comments begin with description of the block and ends with the star and the front slash. The syntax will be, say for example, we are going to write the syntax of the single line comment will be like this. And in the loop, you are going to put your main code, okay, here, and to run that execute repeatedly. There will be the variables also we are going to declare. A variable is the one way of storing the value for later use in the program. A variable is defining by its value type as an int, long, float, etc. by setting a specified name and optionally assigning an initial value. A global variable can be seen in every part of the program which is declared in the at the beginning of the program before setup function. A local variable is defined inside a function in which it was declared. Example, int var void setup, okay, beginning bracket, nothing is required, okay, end of the bracket, void loop, and that will have the looping statements, okay. And similarly, your Arduino programming will have the data types also, right? So the data types are data type, the byte, int, long, float, arrays, right? So then the byte range will be 0 to 255. Syntax will be the word we use a byte x is equal to say 100, right? So another integer data type where we want to represent the whole numbers, we use a integer data type int y is equal to 200. The range will be 32,767 to minus 32,768. Okay, and data type is long data type. Long variable is equal to 8,000, and the range will be so around 21. It will be a billion. Okay, so that range is 21, 47, 48, 36, 47 to minus 21, 47, 48, 36, and 48. Okay, the float, the whenever we want to represent the data in the floating point representation. The floating point representation means that is the the floating point representation is nothing but the whenever we want to represent the real numbers, right, we use a float. Float x is equal to 3.14. Okay, arrays. So int my array, it that size is depends on the data type associated with the declaration. So now the operators, even the Arduino program also uses the operators, right? That operator, arithmetic operator, syntax and its usage is arithmetic operator x is equal to x plus y. Okay, that is there are four arithmetic operators, plus, minus, slash, and star. As we know that plus is used for addition, minus is for subtraction, and star is for multiplication, slash for is division. Okay, if we have any operations related to the arithmetic operations with the use of these operators, we can use this operator, right? And assignment operator is equal to double plus, double minus, plus equal to, star is equal to, and slash is equal to. Okay, so x plus plus is the like increment operator. It is same as x is equal to x plus 1. Okay, and x plus is equal to y, same as same as x is equal to x plus y. Okay, in short form we write that x plus is equal to y, x minus is equal to y, same as x minus y, and x star is equal to y, same as x is equal to x star y. Okay, so comparison operator, and they're also called as a relational operators in C and C++ language. And these operators, which include the double equals, that is used for comparison operator, not equal to, that is represented with the exclamatory mark, and the equal operator, greater than, lesser than, greater than or equal to, less than or equal to. So these operators are used with this. Okay. So x is less than or x is not equal to y, right? Like that we are going to. Logical operators evaluates to, and logical gates. You are familiar with the logical gates and, or, and not. Okay. These logical operators work on the truth table of the logical gates. That is a For OR operator, any one condition is true, then the answer output will be the true itself, right? When you are going to input two values, okay, any one condition is true, then the OR operator evaluates into the true itself. If in a not operator, so that is a negation. Negation means if it is 1, it is going to take it as a 0, not the 1 is 0, not 0 is 1. It is going to take like that. Okay. Then the next one is about the logical AND operator. Logical AND operator is used for representing, it is going to take the, it is going to work on the principle of logical gate truth table and operator. That is, both the conditions are true, then only it is evaluated into the true itself. Okay. So that is about the logical operators. Next, the Boolean operators. As I told that the Boolean operators is represented as true and false. True is represented by 1 and false is represented as 0. Boolean constants true is equal to 2, true is equal to 1 and false is 0 defined in the logical levels, right? So the input output used with a pin mode function to define the levels. Okay. So the pin mode, if it is output, it is represented as it is a function to define the levels, whether it is in the input mode or it is in the particular pin will be in the input mode or in the output mode. For example, if I'm going to give 13 comma output, that means 13 is a pin number which is used for the output. I slash low used to define pin levels. I is equal to 1, on is equal to 5 volts, low is equal to 0 and off is equal to 0 volts. Digital write 13 comma high. 13 is a pin number and high is the voltage level. So high is represented as 1 or it is also represented as a 5 volts. Okay. There are some flow control statements. If else, for, a while and do while or the different control statements, right? Control statements. If statement is used a simple if the condition is true, then it is going to execute some group of statements. Okay. If else, if input is equal to I, then it is going to follow some group of statements that is called as a condition true statements related to that. And if the condition is false, then it is going to execute the other set of the statements. It is bidirectional. Bidirectional means it will have the two options, not like a the if statement, right? It will have the bidirectional statement and it is going to be evaluated only if the comparison results in is in a false value, right? The for initialization condition expression. So a for statement, whenever we want to have a repeated statements, some group of statements wants to be repeated for a specified number of times, right? Then we are going to use the for statement for initialization condition and the loop progress expression. There will be three expressions, right? And those expressions are initialization expression, conditional expression and the loop progress expression. No, that is the for loop, and it will have some group of statements, and those statements will be repeated for a specified number of times. Okay, then we have the while loop executes until the expression inside the parenthesis becomes a false, while some variables value, and you have the group of statements. Here while is the entry condition loop, because when the tested condition is true, then only it will enter into the body of the loop, otherwise it will not execute the statements, right? And another loop is called as a do while loop. It is the exit condition loop, it is also called, because the body of the loop is going to be executed at least once before checking its condition. So this do while loop is also called as a post test condition loop. Okay, and this is while loop is called as a entry condition loop. Okay, then there are the digital input and output pins of their usage: pin mode, pin comma mode method. So okay, digital IO, digital read pin, okay, digital write pin comma value, and we are going to, the syntax will be for digital write is pin comma value, and digital read of pin, it reads a value from a specified pin with a result being high or low value. Digital read if val will be equal to the input pin. Digital write pin comma value outputs are high or low on a specified pin. Digital write pin comma high, pin is set to the high. Example, say x is equal to 13, connect a x to the pin number 3. Okay, and example, int p is equal to 7, connect push button to 7, pin 7. Int value is equal to 0, value to store the read value, void setup. Okay, and pin mode x comma output sets x as a output, and void loop, okay, value is equal to digital read pin, it sets a value to 0. Digital write x comma value sets x to the button value. Okay, so that is a x to the button value. So this is a loop set of motor sensors and etc. And wired loop, it is get the information from sensors and they can send the commands to the motors. And the setup section is used for assigning the input and outputs. For example, motors, LEDs, sensors, etc. to ports on the Arduino. It also specifies whether the device is output or the input. To do this, we use the command pin mode. Okay, setup pin mode 9 comma output. So port, input or the output. Okay, wired loop digital write 9 comma high, delay 1000. Digital write 9 comma low, okay, delay 1000. So that means when you are going to give a high, your LED is on, that will be is equal to 5 volts, and if it is low, it is turned off, LED is off, and it is set to 0 volts. Okay, and see the delay time is set to 1000, that is a 1 second. So with a gap of 1 second, there will be a, the LED will be pin number 9, LED will be high and the low. Okay, so within 1 second. Okay, so that is you know that, so it will be the electronic circuits or works on the nano speeds. Okay, so wait for 1 second or 1000 milliseconds. Then see here, declaration of the variables. As I told, set of loop is set of function is going to use for the initialization of the variables. Int val is equal to 5. So type will be integer and val will be the variable name. Okay, the equals is represented by assignment becomes, and the what is the constant value you are going to assign for that variable. So here wherever you are going to use a val, it replaces the value by 5. Okay, so this is how, say int delay time is 2000, that is it will wait for 2 seconds, delay declared delay time, and int green LED is 9. Okay, wired setup, okay, beginning bracket green LED comma output, that is a pin number 9 is going to be set it as an output pin, and it is going to grow green LED, and this is a initialization where we have done it, it executes only once. Then come to the wired loop, right? As I told, it is repeatedly executes for a several number of times. Okay, so this is the actual execution takes place over here. Digital write green LED comma I, again your green 9 pin number 9, because your already set the green LED is equal to pin number 9 is set to high, that is a high voltage. Okay, and we have to specify the delay time, either how many seconds we want. Okay, you have to specify the delay time. Then delay time low is a voltage represented with a 0. Okay, so digital write green LED comma low represents the delay time. So how much delay, low pin number we are going to make it as a low. So how we are going to using the variables. Int delay time is equal to 2000, that is 2 seconds, and green LED is equal to 9. So these are the variables, right, which we are going to initialize in the setup loop. Okay, setup pin mode green LED comma output. Okay, and wired loop digital write green LED comma I, delay time digital write green LED comma low, delay time is equal to delay time minus 100, and subtract 100 from the delay time to gradually increase the LED's blinking speed. Okay, so that is the reason why we are going to give them delay time minus 100. Okay, to increase the LED blinking speed. Then conditions. As I told, to make the decisions in Arduino code, we use an if statement. If statement are based on the true or false question. Okay, so see here some comparisons. That is what I told. Relational operators we are going to use, or the we call it as the comparison operators also. Greater than or equal to, and less than or equal to. See the symbol. What is the symbol we are using? The less than or equal to is represented the less symbol, and the equal, right? And double equals is used for comparison operator. Single equals is used for assignment operator. So there is a lot of difference between the double equals and the single equals. Single equals is assignment. It assigns some value to the variable. Whereas double equals is a comparison operator. Not equal to, not A is not equal to B, right? So that means you are going to use an exclamatory mark and the equal to represent the not equal to operator. So come to the C conditions, that is the I told that some control statements are there to check the conditions and to make some decisions, right? Whenever you are going to write a problem, solution to a problem, we come across some decisions and conditions need to be tested, right? So when you are going to test the condition, okay, we use if true, then begin perform some action. So close of the bracket. Okay, and example int counter is equal to 0, wired setup beginning bracket serial dot begin 9600. Okay, so that is a 9.6 seconds. Then the loop, say if counter is less than 10, serial dot println counter, it's keep on printing the value from 10 to 1. So in the decrement order. Okay, first it prints a 10, next it prints a 11, counter is equal to count is plus 1. Okay, so initially your counter is equal to 0. So it's 0 to 9. It is going to print the value from 0 to 9 because you are given less than symbol. If you are given less than or equal to, right, then you are able to print the 10. Okay, since you are not specified equals, it stops at the 9 itself. So it is going to print whatever the counter value 0. Next counter value is incremented by 1. 0 plus 1 will be 1. Again it tests the condition. So till the counter value reaches 9 or the 10. Okay. So once the counter value reaches is equal to 10, the condition becomes false because 10 is not less than 10. The termination of the process takes place. Okay. Then come to the input and output. Transferring the data from the computer to Arduino is done using the serial transmission. Okay. To test set up a serial communication, we use the following. So, okay, setup function we use, and we are going to begin with the serial dot begin, okay, which opens the serial port and sets the baud rate for serial data transmission, okay, and it sets a default rate is equal to 9600 bps bits per seconds. Okay. Now the next is, say for example, so println serial dot begin is equal to 9600 milliseconds. Serial dot println hello world. Okay. So hello world, it is going to be printed as a hello world, and loop does not contain any statement. That's why it is a curly brackets as begin and close. No body of is defined in the looping statement. If the answer is true, then perform some action, else perform some other action. So we are going to test the condition here. If condition, we are going to test it here. If the condition is true, then it is going to take some action. If the condition is false, then it is going to take some other action. Okay. So difference between analog, digital and pulse width modulation pins. The analog pins, you have unlimited possible states between 0 to 1023. This allows you to read sensor values. For example, with a light sensor, if it is very dark, you will read 1023. If it is very bright, then you will read 0. If there is a brightness between the dark and very bright, you will read value between a 0 to 1023 value. So in digital pins, you have just two possible states. As I already know, it is represented with a 0 or 1, right? 0 represents the off and 1 represents the on condition. These can also be referred to as high or low, 1 or 0, 5 volt or 0 volt. For example, if an LED is on, then its state is high, or 1 or 5. If it is off, you will have low or 0 volt. Pulse width modulation pins or digital pins, so they output either 0 or 5 volt. However, these pins can output the fake intermediate voltage values between 0 and 5 volts because they can perform pulse width modulation. Okay. Pulse width modulation allows us to simulate varying levels to power by oscillating the output voltage of the Arduino UNO. Okay. And these analog, see here, analog and the digital voltage. Okay, now see the counter, as I already explained this program for you, that if a serial begin DAW is set to 9600 milliseconds, if a loop counter is less than 10, serial dot println less than 10, else serial dot println greater than or equal to 10, serial dot end. Okay, counter is equal to counter plus 1. So answer is true, then you are going to perform some action. Else, if answer is true, then you are going to perform some other action. So in counter is equal to 0, wired setup, beginning bracket, serial dot begin, 9600 wired loop. If counter is less than 10, serial dot println less than 10. Else, if counter is equal to 10, serial dot println equal to 10. Else, serial dot println greater than 10, serial dot end. See now, so you are going to test a condition where counter value is less than 10. Okay, either it is keep on printing the value of counter is less than 10. Else, if the counter is equal to 10, it prints counter is equal to 10. else it is going to print the counter is greater than 10. So your counter is keep on increment by 1. If we want all of the conditions to be true, we need to use AND logic gate. We use the symbols ampersand, that is a 2 ampersand symbol is called as a logical operator AND operator. If value is greater than 10 and value is less than 10, 20, right? If you want either of the conditions to be true, we need to use a OR logic or gate. We use a symbol or operator. If value is less than 10 or value is greater than 20, right? So boolean done will be is equal to true. Boolean done is equal to false. Void set of begin serial dot begin 9600 void loop. If not done, serial dot println hello world done will be is equal to true. Okay. Important function CS serial dot println value prints a value to the serial monitor on your computer. Pin mode, pin comma mode configures a digital pin to read input or write output a digital value. This digital read and pin. Okay. Digital write pin comma value. It writes the digital value high or low to a pin set for the output. Okay. So whatever the value we want to set it, these are the important functions where the println it's going to print the value of a value on the screen. Pin mode it is go configures a digital pin to read or write a digital value. Okay, digital read pin. It reads a digital value high or low on a pin set for input. Digital write pin comma value writes a digital value high or low to a pin set for the output. So a outline essential programming concepts delay infinite loop. Okay, general input outer output are polling or busy or wait or IO. Interrupt processing, timers and internal interrupts, high-level language extensions, code transformations for embedded computing, loop unrolling, loop merging, loop peeling, loop tiling. So delays are essential in embedded systems, unlike high-performance system where we want the program to execute as fast as possible. Delays are used to synchronize events or read inputs with a specific sampling frequency, more on bus wait or IO. So delay 3/3 it is okay. So we do build a delay function. Our reference is the system clock frequency. We use a resistor or a timer to measure the ticks. So each tick is one per frequency. Example for this will be when you are going to assuming a 16-bit processor increment and the jump instruction is 1 cycle each and a 10 megahertz system clock building a 1 second delay. T is equal to 1 by 10 megahertz is equal to 100 nanoseconds and 1 second divided by 100 nanoseconds will be is equal to 10 million seconds. Okay, int I is equal to 50 million 2 ticks for iteration. So we are going to use a back as a label where I value is keep on decrementing by 1, right, until the condition it reaches I is not equal to 0. Go to back, it will be there in the loop until the I value becomes a 0. Once I value becomes 0, then it stops this. Okay, this we call it as the how the label is going to be set with some conditions to be repeatedly execute. So come to the infinite loop. Embedded systems are mostly single functioned and their core application never terminates, and these infinite loops are not forbidden as long as they are done correctly. Okay, so then you take the examples here. Infinite loop example 2, light enum red comma orange comma green. Okay, then loop light is equal to red, no exit from the loop. Delay will be set to 20 seconds. Okay, 20,000 it is given say milliseconds, and light will be is equal to orange. Okay, delay will be 2 seconds, that is a 2000 seconds. So 2 seconds orange, right, 20 seconds green. So again light is assigned the green And again we are going to set the delay time will be 20,000, that is 20 seconds green. Then to repeat this sequence for a number of times repeatedly, right? So we are going to give a go to loop, infinite loop. There is no end for this. That is a continuous process, right? So see, go to label loop. So it's keep on in assigning the red light and orange lights and taking the delay of 20 seconds and the 2 seconds and 20 seconds for different color variations. Okay, so this is all about the Arduino programming. Okay, so